The use of laser scanning technology is not a new approach for electrical substations. It has been used many times. On the internet you can find a lot of materials about this. I will put some articles to descriptions. The main reasons why the reality capture technologies are much better for collecting measurements and other informations than traditional methods you can see on the screen. But usually they are related to safety risks, limited information and very time consuming. Therefore, there is no doubt that laser scanning is faster, more detailed and safer than traditional methods, but it's still not as safe as it could be, because survey engineer should be on site and manually set the scanner in right place. Even if he didn't touch anything, there is still potential risk of electrical shock, burns and other injuries because the personnel forced to work in close proximity to high voltage electrical equipment. And sometimes it's not enough to make measurement once, the user wants to do it repeatedly to check equipment condition status and detect faults in early stages. Mechanical degradations, such as looseness, corrosion or cracks, can reduce reliability and efficiency of electrical equipment. Insulation issues, as leaks or damage, can increase the risk of electrical shocks and outages. Loose connections can reduce the efficiency of electrical equipment. Overloading of electrical equipment can cause overheating and damage to the equipment. Autonomous devices equipped with thermal imaging sensors can detect overheating by measuring the temperature of the equipment and identify other potential safety hazards. Collecting all the type of information could be very time consuming, that's why users don't do it as often as they want. For that type of application where it's very dangerous to present personally and where you need to do constant monitoring, you can use autonomous devices such as Leica BLK ARC. That scanner was designed to be mounted on any robotic carrier so it can be controlled remotely or programmed to do repeatable mission without any presence of human. The device is equipped with dual-axis LiDAR sensor, 4 cameras, an inertial system and internal CPU, which allows you to send all information from it to external systems and can be powered also from external supply, which allows it to be independent of internal memory storage and battery capacity. So if you will put it on some robots with additional sensors such as high-resolution camera, infrared camera, ultrasonic radar and other sensors with combination of artificial intelligence for automatic extraction of desired information, you will get a very powerful solution that will cover and solve all the above topics and problems. And if you will teach your robot to make decisions based on the extracted information, you will reach the maximum level of autonomy. But it will be topics for our future discussions. Today we will have a look at the Leica BLK ARC placed on the spot from Boston Dynamic robot dog. That combination of units allows us to do repeatable missions with predefined rules uploaded to the robot. And I should mention that BLK ARC can work in 2 different modes. Mobile mode, in that mode the device captures data while the robot moving, and static mode. This mode the device can capture data as a typical terrestrial scanner, which increases the quality of data but could take a bit more time for capturing. Settings with the predefined location of static scans could be also uploaded to the robot, so it will make stops in desired location by itself. So today I have a combination of mobile and static data which I registered all together in Leica Register 360 Plus and exported to LGS format. That software is able to combine point cloud from a variety of different sensors, clean noisy points, classify it and georeference your data according to the relevant coordinate system. Usually we call it the preparation step. The next step is creating deliverables. I'll be using BricsCAD BIM software for that purpose, with a combination of the Leica CloudWorx plugin, which allows us to import point clouds without a converting stage and extract some geometry in semi-automatic way. One of the common things which are required for feature extraction is the ground. To generate it, we should extract ground points first and then use them for generating the teen surface. Clip the ground points from all other and then run the points on the grid tool from the CloudWorx panel. In the pop-up window, click the Work Plane Grid tab. In the grid display, set the size of your grid that is desired and check Display. Next, click on the Points on Grid tab and choose which Smart Pick method is desired. Select the ground method. Click Place Points. Preview is not required, however it will temporarily show where points will be placed. Then type in the command line teen command, select all extracted points and click enter. BricsCAD will generate the teen surface based on these points. You also can use the polylines for the surface generation to add clear break lines and curbstones. For extracting standard geometry, we can use fit cylinder and fit steel tools. I demonstrated them in my previous videos. I will put them in the description. Even if you don't have pipes or steels, you can use these tools for objects with cylindrical and rectangular shapes. Before fitting steels, leave on the screen only the relevant points to the object. Run the fit steel tool, specify in the pop-up window catalog if you would like to use some standard size elements, and increase the maximum RMS error. For the terrestrial scanners, you can use standard 6mm, but mobile data has more noise in the cloud, so it will be easier for algorithms to extract the geometry if the maximum RMS error will be 2 or 3 cm. To fit the steel in the point cloud, you should specify 2 points. The first one is the generating section and extract all dimensions, and second point needs to define the direction of extrusion. For the cylindrical objects, use the Fit Cylinder tool. Also choose the catalog if it's needed and increase the maximum RMS error. If you have a noisy point cloud or a very short length of pipe, then use the Fence tool to select points for fitting. Keep in mind that you should fence only points relevant to the cylinder. For non-standard elements, use the native BricsCAD modeling tools. You can switch the workspace to modeling to get all the relevant tools. Most of them use sections, which you can easily extract from the point cloud. Check the below tools. When all the main geometry will be done, you can modify it with the below tools. Group assembles of elements which are related to a single object and save it as a reference block. Next, you can just copy-paste the block into the desired location. Also, you can create some elements directly on the existing surfaces and use the propagate tool to identify a common area between two details and multiply selected elements automatically to all similar places. That unique tool can greatly speed up all modeling processes if you have a lot of repeatable elements and you need to add some changes to all of them. When all your model will be done, apply some materials to it to perform better visualization and later use them as a separator. When you bring the model to Twinmotion, there is an option to group elements by material. A standard BricsCAD comes with a larger number of free materials and textures, but even with all these materials at your fingertips, you might still want to add your materials to the library. Although you can create your texture from scratch, it's often easier to simply download them. Here's a useful article with a list of sites where you can download free materials and textures. The easiest way to add the materials to a model: open the Render Material panel, select the material you want to add, the mouse cursor will become a brush. Just select object which you want to colorize with the selected material. The material will be applied to the whole object. Hold the Ctrl button to assign the material to each face in turn. To extract wires, I prefer to use the Cyclone 3DR with an electric line extraction script. I demonstrated it in my previous tutorials about TRK data processing. To easily separate the wires point cloud from all others, use the below workflow. Import created model with all structures from the BricsCAD. I use the DXF format, so in my case I need to convert this model from CAD model to mesh. Use the mesh from geometry tool for that. Select the mesh and the point cloud and run the separate according distance filter. Define the desired range of filtering and click the preview. It will split the point cloud into two parts. First, it will be points that close to the model, and second part of the points, it's points that far than defined range. To split all wires into different segments, use the distance filter. I also demonstrated this tool many times in my previous tutorials. Next, apply the electric line extraction script to each segment. To convert extracted wires polylines to the model, use the pipe tube along path tool. This command creates 3D mesh corresponding to a circle extrusion along the path. Select one or more polylines to extrude along. Define the radius of the circle used for the extrusion computation. I used 1 cm radius to generate the model of wires. You can also use this tool for generating hazard areas. For that, just specify a higher radius in extrusion parameter settings. Then colorize these meshes and make them transparent. It will give you a clear representation of dangerous areas. To combine all models and visualize them, I used the Twinmotion. It's a real-time 3D architectural visualization tool that easily produces high-quality images, panoramas and standard or 360 VR videos in seconds. This is one of the best visualization tools for architecture, construction, urban planning and landscaping professionals, which is included in the BricsCAD BIM license. All users with an active full commercial BricsCAD Pro or higher BIM Mechanical or Ultimate license can claim a free permanent Twinmotion license also. To import models from the BricsCAD, run the Twinmotion and the BricsCAD simultaneously. In the BricsCAD BIM workspace, go to the View Datasmith Twinmotion section and click the Connect button. In the Twinmotion, click the Import button and then select the Direct Link option. The software will identify which project at the moment opened in the BricsCAD and will synchronize it with the current scene. After import, you will be able to interact with the model, for example, apply other high-quality texture on it or add additional decals and other elements. To import regular models from other sources, use the same import button but select the geometry mode instead of direct link. When all models will be imported, play with colors, add light, sounds, some vegetation and other stuff to bring life into your scene. You can use this software for the below purposes. Make basic measurements between objects, the sag of wires between objects and point clouds, etc. Place construction machines and other objects to plan the site work and find out possible collision in early stages. Visualize hazard and dangerous zones. Activate and visualize different power lines to see which elements will be active. Train your employees to respond in difficult environment conditions. Add tags with specification information of equipment to provide asset management. Work in VR mode for a better immersive experience. Publish your project to cloud storage and share access with your colleagues to create your own little metaverse. Via browser, you can open this project not only on computers but also on tablets and phones.